All right, great. Hi, everyone. Thanks for coming to my introduction to deontic logic, and thanks to this series for asking me to participate. So my name is Melissa. I'm a professor at Columbia University in New York City. Okay, so just as some preliminaries, so I'm going to present deontic logic sort of as it's practiced as a branch of modal logic. In these slides, I'm going to base my exposition on Paul McNamara's Stanford Encyclopedia of Philosophy entry, and also on my own professor, Wes Holliday's slides from when I took modal logic for the first time, which was in 2012, which was a class that I really loved and still think about a lot. I did notice actually the other day when I was preparing these slides that McNamara's Stanford Encyclopedia, his SEP entry, has since been updated, but there is a link at the end of these slides in the bibliography that can take you to the original version. It's been updated. I'm sure that it's interesting and expanded now, but what I'm basing my exposition on is actually the older version. So what I'm going to do is introduce standard deontic logic, sometimes called SDL for short, as a branch of modal logic that you might know from a textbook. And then I'm going to present sort of some of standard deontic logic's discontents or reasons to be unhappy with the standard theory, which have sort of paved the way for subsequent developments in the literature, including the contemporary literature and including some of my own work that's sort of on one of these classic problems with SDL. Okay. So let's just talk quickly about the object language. So deontic logic studies sort of officially the logic of obligation and permission, so moral or more generally deontic concepts, as you might expect them to appear, for example, in legal reasoning. The basic language is a basic modal language with the box operator written as O for obligation or for ought. So this is the signature of the language. So the well-formed formulas are, a collection of atoms, PQR, then negation and conjunction, which together will take care of the Boolean fragment of the language propositional fragment. And then instead of your box phi, or as a version of the box, you have an O phi, and that stands for ought. The dual of ought, because we have both obligation and permission, is often written as M for may. So may phi is a defined operator. It's may phi is true just in case not ought not phi is true. It's not the case that you ought not to phi. Means that you may phi, or at least that's the paraphrase as we usually employ it. So just the way that disjunction, for example, can be defined in the basic language with negation and conjunction and De Morgan's laws, you can define may in the language with ought using duality. The idea of treating ought and may as obligation and permission goes back at least to von Rich's deontic logic, that's in 1951. So let's just think about the expressive power of the language. So it's sort of taken for granted in a way that this language captures obligation and permission, obligation via this primitive operator O, that works like a box in the modal language, and then by duality, we have permission or may. But how in this language would you say that phi is forbidden or strictly optional? It's, again, the thought is that the expressive power of the language as we have it should be able to capture these. So you can think about that for a second. How, just in terms of ought and negation and conjunction and so on, would you say that phi is forbidden? Well, it seems like you could say that phi is forbidden just in case you ought not phi, or equivalently, given duality, that it's not the case that you may phi. Likewise, if phi is strictly optional, right? You might say, well, it's not the case that you ought to phi, and it's also not the case that you ought not phi, or that you ought to refrain from phi. Equivalently, again, given duality, that's just the conjunction may phi and may not phi. Right? So again, test your intuition, see if that seems right. That's sort of widely accepted that, at least, for example, to say that phi is forbidden is to say that you ought not phi, where the ought is taken in this particular sense. Right, and forbidden is taken in that same sense, if you will, the deontic sense. All right, so just to interpret the language again, everything's still standard here. Interpret the language on Crypty models, right? So that's a model M is a tuple consisting of a universe of worlds, big W, right? A binary relation on the worlds in big W, that's the R relation, the modal accessibility relation, and then a valuation function V for the atoms of the language. So WRV, that is when two worlds W and V in big W are related via the R relation. We're taking that here to mean that the world V is deontically ideal relative to world W, right? So this is a world anchored notion. So one world W sees another world V via the R relation. That means that by the lights of W, V is ideal. It might fail to be ideal by the lights of a third world, say U. So the sentence phi is true at a world W, just in case phi is true in every world that's deontically ideal by the lights of W. So that's just the standard clause for box. So here it is. Phi again is true at a point of evaluation consisting of the model M and a particular world in the model W, just in case for all V and W such that W are V for every deontically accessible world, and V satisfies phi, just what we call the prejacent, right? The sentence when you take the ought operator off. So with this construal of the R relation, we can ask what properties should the R relation have? Sort of what mathematical or structural properties should R have? So this is a conceptual question, right? It's kind of a question about the structural nature of deontic ideality, right? We're trying to come up with or trying to ask whether we can imbue the relationship R on possible worlds with structural properties that reflect the nature of deontic or moral ideality. So maybe there aren't any such properties. Maybe at that abstract level, you can't say anything. That's at least a possibility at the outset. But one thing, and in that vein, one thing seems pretty clear. We shouldn't assume reflexivity, right? It's not always the case that a world W is deontically ideal by its own lights, right? So of course, a natural example would be the actual world. One would think, according to most standards of deontic ideality, our world is not perfect. And so it's not deontically ideal by its own lights. It's a world that does not see itself, that's not R related to itself along the deontic accessibility relation R. What that'll mean, of course, in the object language is that box phi arrow phi, that axiom is not going to be valid, right? Here the box again is ought, so ought phi arrow phi is not valid. Another way of putting that is just the deontic modality is not an alethic modality, right? That something is necessitated deontically doesn't make it true. Alethic here meaning just true. So deontic logic is a logic in which for the relevant type of box, again, the O, box phi arrow phi is not valid. And that's because R is not reflexive. However, in SDL, one does assume, and again, test your intuitions, that R is serial. So that means for any world little w in our universe, there is some world V such that W are V. So that what that means, right, is that no world is a deontic dead end, no matter how bad the actual world, well, no matter how bad any world is, it always sees something, some other world or itself as deontically ideal. Maybe one way of thinking of that intuition is that morality can't strand you in modal space. It can't be that morality tells you that, no, there's nothing you can do in the moral sense of can. So here's sort of what that would look like, right? Hopefully these sorts of models are familiar. So here's two worlds, W and V, right? And the R relation is represented by arrows. So here in this sort of mini model, if you're just thinking of it as these two worlds, W is R related to itself, and it's also R related to V. But this model violates the seriality of R because seriality says every world sees some other world via the R relation. And here V is a so-called dead end, right? V doesn't see itself. There's no arrow from V to itself, and there's also no arrow from V to W, and those are the only two worlds, right? So R is not serial in this picture. And so this is not a possible modal model according to SDL. The seriality of R corresponds in correspondence theory to the D axiom. So that means that whenever R is serial, the sentence not ought bottom will be true, right? So that's a validity in deontic logic. Equivalently, given duality, you can write the D axiom as M top, right? And again, a way of glossing it is nothing logically consistent can be deontically obligatory. So again, a way of looking at that is if may top is true, right? That means that, well, top, the tautology is true at any possible world, right? So may top will be true for any world except a world like V, which sees nothing, right? Because then here there's the existential statement that there's some world that V can see where top is true is false just because V can't see anything at all. That's the only way that this sentence could fail to be true. Okay, so no reflexivity, right, for R in deontic frames, but maybe yes to seriality. Again, I'm just sketching how standard deontic logic works. So standard deontic logic, that's my puppy. That's it. Standard deontic logic is just the modal logic KD. So K because it's a normal modal logic, and then D because it includes the seriality axiom D. So officially, right, if you're sort of axiomatizing, and this is Hilbert style, this logic is going to have all propositional tautologies as axioms, law of the excluded middle, and so on. The rule of modus ponens, so arrow elimination, right? For the arrow, the material conditional defined in terms, which you can define in terms of conjunction and negation. Then the K axiom, which should be familiar to you, but that's just, right, think of this as distributing the box operator O across the material conditional, right? So if the implication phi arrow psi is necessary or ought necessitated, then ought phi will entail ought psi. Then there's the rule of necessitation, right? So if you're starting out with some theorem phi, then you can conclude ought phi, right? This is just to say, right, if you're starting out, for example, with some propositional tautology like P or not P, then that's going to be true at every deontically possible world. So ought P or not P will also hold. And then, of course, we have the D axiom. Here, not ought bottom or equivalently may top. So that's it. That's standard deontic logic, the modal logic KD. But another logic that you can consider in this framework, which is one that I used, for example, in my dissertation, is goes a little bit further than that in terms of putting restrictions on the R relation. So this is called standard deontic logic plus. In the terminology of, for example, McNamara 2010. So SDL plus is a different modal logic. It's a normal modal logic that adds a further axiom to what we just looked at to SDL. This is the axiom in the object language. It ought to be the case that, in parentheses, ought phi entails phi, right? So what does that correspond to, right? That's kind of maybe a surprising thing to sort of think about. Again, if you want to pause and sort of think about what that would be, you're welcome to, right? We can ask the question in two senses. We can say, what does that sort of correspond to in natural language? If you were going to read that sentence in pink, it would be something like, it ought to be the case that everything that ought to be the case is the case, right? As a restriction on R in frames, this corresponds to a property that's sometimes called shift or secondary reflexivity. So what it says is that for any two worlds, right, W and V, if W sees V as deontically ideal, then V sees itself as deontically ideal. So that is, in a sense, a sort of secondary reflexivity, because if you step over one step along the R relation from W to V to some world V that's in the image of the R relation, then V steps to itself. It's in that sense reflexive, right? So it's reflexive one step over. So here's a little picture, right? So again, if W can see V via the R relation, then V can see itself. Any world V, which is in the image of the R relation, so it's hit by some arrow from some world, then it's hit by an arrow from itself to itself, right? And I take it that the intuition here is something like, look, if V is an ideal world, right, deontically ideal, it has to think that it is itself deontically ideal. So ideal. So there really could be a genuine, I mean, given the way the modal models work, there could be a genuine variety in modal space of which worlds count as deontically ideal. Deontic ideality depends on which world you start from, right? Two worlds, W and U, can see different worlds as deontically ideal, but any world that counts as deontically ideal from any point of view needs to count as deontically ideal from itself. Because think how weird it would be, for example, if sort of starting out from W, you say, okay, it should be the case that V. So we sort of go to V, and then V doesn't like itself though, right? By the sort of local moral standards at V, you get sent right back to W or something, right? That, it seems like that would be very odd, right? In fact, it would be so odd that it sort of couldn't happen according to these models. Again, I think that's an interesting property to think about. It's sort of relevant to some of my own work, but just to keep track of how the logics are working, right? SDL plus in the notation that we're using is just SDL, right? Which is again, just the modal logic KD, normal modal logic KD, plus the axiom, right? We're closing again under the axiom. It ought to be the case that ought phi entails phi, right? Which sometimes that axiom is called the U axiom. So therefore, SDL plus is the normal modal logic KDU. You know, for people who are familiar with soundness and completeness, right? So we've got these models and we've got these logics, right? SDL is sound and complete with respect to the class of Kripke models in which R is serial, right? So, you know, everything that is true, that is valid in those models has a proof in SDL, and everything that SDL can prove is valid in those models. Likewise, SDL plus is sound and complete with respect to the class of Kripke models in which R is serial and shift reflexive, right? So this is a smaller class of models than SDL because it requires, right, that every world like this, V that's hit by the R relation sees itself. Okay, so, and the way that you prove that sort of standard completeness techniques with Lindenbaum lemmas and so on, which you'll probably be familiar with from textbooks. Okay, so let's look at just some theorems of our standard deontic logics, right? And again, we can sort of class them in terms of why these different things are theorems given the way that the system is built. So in virtue just of the fact, right, that these are normal modal logics, right, they have all the theorems of K. So in particular, I'm using the terminology here that I've seen in the literature for these. This will validate a property that we can call agglomeration, right? So if ought phi and ought psi is true, right, then we have ought phi and psi. Again, just think here of the ought as a box, right? If every ideal world is a phi world and every ideal world is a psi world, then every ideal world is a phi and psi world. Likewise, in scope, what I call in scope disjunction introduction will be valid, right? That just introduces a disjunction in the scope of an ought or a may for what it's worth. So ought phi entails ought phi or psi. Again, if every ideal world satisfies phi, then every ideal world satisfies the weaker property phi, Boolean or psi. In virtue of the fact that all of these models are serial, right, they satisfy all theorems of KD. So in particular, ought will entail may, right? This is just a box to diamond inference in a serial frame, right? So if all ideal worlds are phi worlds and there must be some ideal worlds, that's what seriality guarantees, then there is at least one ideal phi world. Finally, in virtue of shift reflexivity, right? So this is just for SDL plus, you'll get this as an axiom, right? If it ought to be the case that it ought to be the case that phi, then it ought to be the case that phi. I don't think I have super clear intuitions about something like this, but you know, again, what it will say in terms of the logic that we're generating is if somebody tells you, you know, well, it ought to be the case that it ought to be the case that P, but it's not the case that it ought to be the case that P, then they're wrong, right? They've logically contradicted themselves in our logic. So think of a counterexample if you can, right? In fact, that's sort of the name of the game from here on out. So, you know, we have all of these theorems, and then we should ask, are they right? This is just the standard, you know, view, but the standard view can be, you know, should be interrogated according to various intuitions that we might have. A way of asking this question when we just say, are these right? Well, of course, they're right in terms of the models that we've defined, but are these really a priori truths about obligation and permission? That's sort of the question that we're asking ourselves, right? If this is the correct logic of permission and obligation. So in particular, when we ask, are these a priori or logical truths about permission and obligation, I picked agglomeration and scope disjunction introduction because lots of people have had the intuitions that no, they aren't, right? So now we're starting to ask ourselves, is it really true in terms of our intuitions about sentences for different substituents for phi and psi? Or, in terms, if you want to put it a different way, if it even is different to think this way, in terms of our notion of obligation, could you be in a situation, for example, where you're obligated to phi and obligated to psi, but it's not the case that you're obligated to phi and psi? Likewise for in-scope disjunction introduction. So there are sort of purported, what you might call ordinary language counterexamples. For one, for agglomeration, it's been proposed that the general class of moral dilemmas are counterexamples to agglomeration, cases where it's sort of the antecedent of that big conditional holds, but the consequent doesn't. That's an idea that goes, again, at least back as far as Lemon in the 60s. And then for in-scope disjunction introduction, it seems like there can be instances where ought phi, the sentence strikes us as true, but ought phi or psi strikes us as false. And this is known in the literature as Ross's puzzle. And that is from an article by Ross in the 40s called Imperatives in Logic. All right, so let's just look quickly at this. There are many, of course, examples of moral dilemmas, but just, for a basic one, suppose that I've been absent-minded and I've accepted an invitation to go to Bob's wedding, and then later I accepted an invitation to go to Alice's wedding, but it turns out that they're on the same day, at different ends of the earth. And so it just is impossible for me to go to both. Now I might say, well, I mean, I did accept the invitation to Bob's wedding, so at least in that sense, I ought to go to Bob's wedding. I also accepted the invitation to Alice's wedding, so maybe it's also true that I ought to go to Alice's wedding. But in SDL, it can't be, at least if we're accepting that sort of necessarily using this box to quantify sort of not just over deontic possibilities, but over all our possibilities, say, that necessarily if I go to Bob's wedding, then I don't go to Alice's, right? I can't do both in a sense of can't that isn't deontic, that is sort of stronger than deontic. It's sort of a practical or a lethic sense. Then we have a contradiction, right? It just couldn't be true that in STL, that I have conflicting obligations unless I'm obligated to do the impossible, obligated bottom, right? And that can't be that can't be true in a serial frame, right? So, so someone like Lemon might just say, but that's just not true. It's true that you can have a moral dilemma, that you can have conflicting obligations, and you shouldn't, in the logic of SDL, be able to conclude from that that the absurd, that you're obligated to do nothing, or that or that nothing follows, or that everything follows, which is what you would get from a contradiction, right? For Ross's puzzle, this is, I believe, Ross's only example. It just seems like sometimes you can be obligated to do something without being obligated to do it or something else. So his example was, suppose you're under an obligation to mail a letter. It can be true, sentence 3, that you ought to post the letter. And it can be false, that you ought to post the letter or burn it. That's a perfectly, again, coherent moral or deontic situation to be in. But again, in SDL, in the proof system that we have, 4 is a consequence of 3. Right? So it's impossible, again, in our system, for ought phi to be true while ought phi or psi is false. And then you might ask yourself, well, but why does this strike us as false in that situation? What does this sentence communicate that is not captured by this sentence of the formal language, and so on? So I just want to close by making a couple of remarks about methodology, right? Both of these puzzles and several others that I haven't had time to mention have generated a huge literature. They tend to start out in SDL in the sense that there's sort of asking what minimal ways of expanding the apparatus of SDL or weakening the apparatus of SDL can we use to capture these inferences, and what other inferences will we get, what new logics will we generate, and so on. But let's just say, I'll just close by saying something sort of big picture about methodology. Here, a lot of people think, well, deontic logic makes contact with natural language semantics, right? And so you might ask, well, if we're sort of interrogating our intuitions, for example, about sentences like this, you ought to post the letter or burn it, and maybe why the meaning of that is not adequately captured by this modal formula. That we're doing natural language semantics more as a branch of linguistics, something empirical. We're asking, well, how does a natural language sentence, say in English, right, match up to the well understood truth conditions of this modal formula in this class of models? And we haven't really done, I mean, in this talk, we certainly haven't done anything empirical in the way that linguistics would investigate this. We haven't seen whether different of the world's natural languages vary with intuitions native speakers have about sentences that one might formalize this way. We haven't asked ourselves what other patterns of usage might differ across languages that would predict whether they would sort of get intuitions like this in Ross's puzzle style cases, right? But there is research of that kind. It's just something that we haven't really gotten into, right? And so this is where the methodology can change quite a bit, because now you really are doing something empirical. Logic is not generally accepted to be empirical, right? It's not about research into natural language. But the purported counterexample to the Ross inference, for example, comes from natural language semantics, or comes from our intuitions about natural language sentences. Insofar as I think there is a lot of a current to try and sort of save SDL or save standard deontic logic in spite of these purported counterexamples, think of the methodology of Grice in Logic and Conversation, trying to take purported conversational counterexamples to inference patterns that are valid in propositional logic, let's say, and just saying, oh, well, there's pragmatics here as well as semantics, and we can keep the semantics simple, and we can explain via pragmatics why we have these other intuitions. There is a lot of that. There is a lot of that conservative impulse in the literature to sort of save or fit natural language to standard deontic logic, or SDL plus, maybe. And so you might ask yourself, well, what's at stake in that conservative project, right? Why would we want to do that in the first place? And maybe, I won't speculate exactly on what motivates Grice in Logic and Conversation, but it seems like you might want to say, well, to have a simple or elegant theory, to have a theory of semantics that's well understood formally. And in particular, of course, we have looked at two formal results that we have here. We have soundness and completeness results, right, for SDL and SDL plus. So if I start monkeying with the semantics, because I'm trying to block the inference in Ross's puzzle, or I'm trying to create a logic where moral dilemmas are consistent, I'm going to lose my soundness and completeness results that I just canvassed. Of course, that doesn't mean that other more complicated, let's say, soundness and completeness results for these other logics aren't possible. In fact, they're not only possible, they're actual, right? So there's a variety of soundness and completeness projects for logics that build on the resources of SDL or SDL plus, but are trying to capture some more of these natural inference patterns like the ones that we just saw. So yeah, I mean, as somebody who's kind of worked on that myself, I might think, well, so what, right? We throw out maybe some of these old soundness and completeness results, but that just means that we get new ones, right? Or we see where we find the limits of whether we can have soundness and completeness results for a language with the relevant expressive power to capture our deontic concepts. All right, so that's about it. Thanks so much for listening. And again, I have a little bibliography here for anybody who's interested. Thanks so much.